Hi and welcome to video 8, Unit 4, Topic 1, Math Methods. In this video we're going to continue looking at examples and in this case another measurement example. So I'll just zoom in on this a little bit and you can see that in example 8, my apologies, we're being asked to maximize an area that is shaded in a given diagram. Now often for the Queensland system, an area shaded in a diagram is going to imply a complex familiar at best. If a diagram is provided, it usually is enough information. But in this case, there's a lot of other information missing, so it may go beyond that, but probably we're looking at a complex familiar type question. A square sheet of paper has dimensions 10 by 10. So let's start noting the information that we have already. 10 and 10. In fact, I might put this 10 down the bottom to leave some space. So at the moment I'm doing that step 1. Build and understand the information that I have. Choose a point P on the top edge. That's been done for us. Join P to the bottom right hand corner. So that's happened just here. Create a 45-degree triangle on the top left hand corner using corner P. So we've created that 45-degree triangle. This is the 45 degrees. So it says in the top left hand corner. So it's talking about that top left hand corner triangle there. Find the maximum area of the shaded region. So there must be enough information here for this question to work. We know, of course, that the total area is 10 by 10. And that's 100. And it's in centimetres, so 100 centimetres squared. So that's what we have so far. So what we're trying to do is maximise the area, which I'll call A. So this is step 2 now. Let A equal the area shaded. To calculate this area though, I've got a couple of options. The first and most obvious option is to look at this grey area and see if I can find a representation based on some other value for the area of this shape. It's not any special quadrilateral, so I don't have any special rule. It's not a trapezium, for example. But I could split it up into 2 triangles. So maybe I can do something with this area 1 and area 2. That's the first and most obvious way of doing it. And you know what? Probably we can. But there is an easier way. So I'm going to rub that out and have a look at the easier way. The easier way would be to go, well, what if I knew this area and this area? And this is a 45-degree triangle, so it's isosceles already. That area is pretty easy to work out based on not enough information to work it out exactly, but it's an optimization question. So I could just say, well, A is equal to 100, the total area, minus area of triangle 1 minus area of triangle 2. That will be the area shaded. So this is me now imagining ways to approach this question. Now we do need some variable here. So let's create a variable and see if we can build the area out of that created variable. So I'm going to create a variable here. We'll call this x. And I know that this angle is also 45 because this is a right angle. So therefore this is also x. And it's going to look like I've eliminated all the variables at once. But imagine if I called this y. Then I might say that x plus y equals 10. And then I would say that y equals 10 minus x. Some people might come along and say, well, forget that. I already know, just by my understanding of the geometry here, that that is 10 minus x. Which will mean it doesn't look like we're quite doing that step 2, step 3, eliminate variables. And that's fine. I'm going to work with just x. You might introduce a y, you might introduce a z here, and then prove that z is equal to x. But let's just work with the geometry and our understanding of isosceles triangles and squares. So the area of the shaded region is equal to 100 minus area 1 minus area 2. But what is area 1 and area 2? Well, area 1 is going to be equal to a half x times x, which is a half x squared. Hopefully you can see that. And area 2 is going to be equal to a half times 10 times 10 minus x. So again, we're looking at a half times length times height and a half times length times height here. Got that a bit skewiff, but there we go. And this simplifies down to give 5 times 10 minus x, or maybe we'll use 50 minus 5x. So there's our two areas. and therefore the overall area is equal to 100 minus a half x squared, I missed there, squared, minus 50 minus 5x. So there's my total area. And now I can write this in simplified form. 100 minus 50 is going to give me 50 minus a half x squared, and then minus negative 5x becomes plus 5x. So now I've got a complete representation of the area of my shape, the shaded area, and I want to optimize this to find the maximum area of the shaded quadrilateral. And so I'm going to optimize this by recognizing A is already in terms of one other variable only, x. Therefore I can calculate dA dx, which in this case is going to be equal 50 disappears, 2 comes out the front to give me negative x plus 5. I'm going to let dA dx equal 0, and therefore negative x plus 5 equals 0, and x is equal to 5. So we're saying that hopefully the maximum area will be when x is equal to 5. Now of course, to check the maximum area, I consider d squared a dx squared, which in this case is negative 1, which of course is negative in all cases, and therefore we're dealing with a maximum, and therefore when x equals 5, a is maximum, and the maximum area A is equal to 50 minus half times 5 squared plus 5 times 5, and do that calculation. It's 50 minus 12.5 plus 25, 62.5 centimeters squared. Now let's just pop up to the diagram again. We can never really trust the diagrams, but this looks pretty good. I've got no reason to believe it's wrong, and when I look at the diagram I can see that that shaded area, 62.5 is a reasonable representation. So we're into our ballpark. It's a bit over half, and a half of 100 is 50, so we're happy with that, and everything I've done makes sense. Just running through quickly the steps. I've got step 1 there, I've got step 2 here, and then I've got step 3 in and around here, and then I've got step 4 here, step 5 here, and step 6 here. They're my optimization steps to solve any problem, but it's pretty heavy at the front end. Step 1 is quite difficult in terms of interpretation, but it gets easier as you practice more. All the best.